All right, so let's look at this question. So in this question, KC is an arc of circle center T. BC is a tangent to the circle at C, and TB is a straight line TC, which is equal to 8 root 3 centimeters, and angle KTC is equal to 60 degrees. So we are to calculate the length of KB and also look at or find the shaded portion, and then we correct our answer to 3 significant figures. So this question is one of the WASSCE question. They just ended WASSCE maths, core maths question. So we are looking at how we are going to solve this question. So let's look at the sketch here. Before we can look at or go ahead and solve the question or find the answers to the question, let's identify some key points in the diagram. So we are saying that KC is an arc. So this is KC, which is an arc, and the center of the circle is T. So if we are saying this is an arc, then let's continue with the circle. Let's draw the circle. So from here, we can draw the circle. Good. So let's say this is our circle and T is the center. So since T is the center, then this line from T to C is what we call the radius. Have you gotten that? Good. So this is the radius, and the same thing here, T to K is also what? The radius. So it means that we have two radii in this question. So once here is 8 root 3 centimeters, then automatically TK is also 8 root 3 centimeters, because these are the two radii and they are the same. Good. Now once we have these two radii, so any shape, so let's look at this shape CTK. So this portion you see here, so when you have two radii bounded by an arc, what name is given to that shape or that part of a circle? A part of a circle having two radii which is bounded by an arc is called what? A sector. So the sector in this diagram is what? CTK. That is the sector, and the angle of the sector is what? 60 degrees. Remember that we have major sector and minor sector. By looking at this, you can see that the 60 degrees gives us what? The minor sector. So at the end of the day, we are going to deal with what? The minor sector. Good. So once we are able to identify this part as a sector, then we can move on. Now, we are also saying that BC is a tangent line. So BC is a tangent line, and it is a tangent to the circle. So if we have this line as tangent and the radius, the line drawn from the center to any point of the circumference, we know is the radius. But looking at where the tangent line passes, you see that it intersects with the radius. So if it intersects that, then in circle theorem, whenever you have the tangent line which touches the circle at a point where a line drawn from the center to intersect, then automatically that angle formed there is a right angle. Have we gotten that? So here will be right angle, because we are saying that this line is what? Tangent line. Then it is perpendicular to what? To line what? TC. If it is a tangent line, then so line BC is a tangent line, then it is perpendicular to what? Line TC. And for that matter, the angle formed at their point of intersection is right angle, and that is what 90 degrees. Good. So if you are able to identify that this angle is 90 degrees, then the whole of this shape T um, TCB or BCT, then this shape becomes what? A right angled triangle. A right angled triangle. Good. So looking at the entire diagram in the question, you see that the whole entire diagram is a right angled triangle because this particular angle is what? Right angle, and it is 90 degrees. So if we have right angle here, then the whole what entire diagram is a right angle triangle. Have you gotten that? Good. But in the right angle triangle, we have what? A minor sector within, and that is what we are going to look at. Good. So once we are able to identify these portions, then we can go ahead and then tackle the main question asked in this what question. Good. So let's quickly look at the first one. So we are asked to find what the or calculate the length of KB. So let's identify KB. So this is K and this is B. So we are to find this particular length. That is what we are looking for. But how do we find this length? Before we be able to look at that, we need to consider what? Length TB. We have to find the whole entire length. Then it will help us to find what? KB. Already we have been able to identify that TK is 8 √3 centimeters. So it is left with this portion. But how do we get this portion? Unless we get the whole length, then we subtract the length of TK from it. Whatever is left gives us what? Length KB. Have you gotten that? Good. But since we have this angle here, this is 90. So in this case, we can also look at this angle here. But how do we find this angle? Since we have two of the angles in the triangle, then we can just sum the two angles and subtract from 180, and we get the angle left. So if we are to find the angle here, then we are getting what? 30 degrees here. But that's not our concern. That's not what we are looking for. But because we may need this to work for the rest of the question, that's why we are looking at this. So since we have this angle here and we have this length here, then we can find this length here using the trig ratio. So we have the sine, cosine, and then tangent. So these are the trig ratio. But which of them will be appropriate since we are looking for this? Because we have angle 30 here and we are looking at this, and this part is also 90 degrees. It means that this is what? Right angle triangle. So using the trig ratio, I think we can use sine, we can also use cos. But remember that if you want to consider sine, then we are going to use this particular what? Angle. If you want to consider what? Cosine, then we are going to look at what? 60. So let's use what? Sine. So to get the entire length, we can say that sine what? 30 degrees should be equal to, because we are saying that if you use the trig ratio, that's where we have what? SOHCAHTOA. So sine is what? So, which is what? Opposite over what? Hypotenuse. Good. So opposite, where is opposite? If you are using 30, then what is the opposite of 30? 30 is facing this length. So this is opposite to this length. So wherever it is opposite, that's what we are using. So it means that opposite is here. Have you gotten that? Good. So we have 8 √3 divided by, then we are talking about TB. So we have TB. So to get TB, then we are to find 8 √3 divided by sine 30 degrees, which gives us what? So we are getting, so if you use your calculator, then we are getting what? 16 3 centimeters. Good. So that is the length of what? TB. Good. So once we are able to find the length of TB, then we can quickly find KB. But how do we find KB? We only have to what? Subtract TK from what? K from TB. Have you gotten that? Good. So our first question, which is A, that is line KB is equal to TB minus TK. So we have TB as what? 16 root 3 centimeters minus, and TK is also what? 8 root 3 centimeters. So this gives us what? 8 root 3 centimeters. Good. So that answers our first question. Now let's look at the second question. So the second question says we should find what? Area of the shaded portion. So it means that we are looking at this portion. Meanwhile, the entire shape is this, but we are finding only this part. That's we are looking for the area of this part. But how do we get the area? I've already explained that to get the area of this shaded portion, what we'll do is we'll find the area of the entire what diagram, and then we find the area of the sector and subtract from the entire what area, then we get what area of the shaded portion. Have you gotten that? So looking at the entire diagram, you see I have already said that it's a right angled what triangle. So we have this as, so this is the entire shape. So here is 8 root 3 centimeters, and then so we have here as T, here as C, here as B. So we got TB as what? 16 root 3 centimeters, and we have here as what? 60 centimeters. Good. So once we have here at 60 degrees, we know 2 of the size, then we can apply this formula. So the area becomes what? Half of TC times TB times sine 60 degrees. So we can apply this also. We are saying that whenever you have two sides of a triangle with an included angle, then we can apply this what formula here. We can use it, and then we find our area. That's what we are doing. Good. So we have half times, so TC is what? 8 root 3 times BT is what? 16 root 3 times what? Sine 60 degrees. Good. So if you use your calculator, then you are getting the area for the entire diagram as what? 96 root 3 centimeters squared. Good. So that is the area for the entire diagram. Now let's also look at how we can find the area of the sector. So let's draw our sector. So this is our sector. We have here is 8 root 3 centimeters and 8 root 3 centimeters, and then we have this angle here which is 60 degrees. So I know you remember how to find area of a sector. So area of a sector is giving us what? Theta on what? 360 degrees times pi r squared. But in the question we are to take pi as what? 22 on 7, and we already know r as our radius, and that is what is given here. So we only do substitution. But what is theta? Theta is what is given in the question. That is the minor angle, which is what? 60 degrees. So we only do what? Substitution. So we have 60 degrees divided by 360 degrees times, so pi is given as 22 on 7 times, then we have the radius as 8 root 3 all squared. So if you use your calculator, then you are getting 704 all divided by 7 centimeters squared. Good. So once we know this, then we can find the area of the shaded portion. So it becomes area of the shaded portion. We only to subtract what area of the sector from the entire diagram. We got this as entire area of the entire diagram. So it will only be what 96 root 3 minus 704 all divided by 7, which will give us